Hello guys, in this video we're going to learn how to delineate modeling regarding particle movement in case of a river and a drain from an injection and a production well. So let's start the video. It's a Simcore software modflow 8. We make a new file, our folder rain, river and drain, named it exercise 15. Open grid and a mesh size. Number of layers 2. Model thickness 20 is okay. Number of rows increases up to 30. Model extend up to 300 meter. Columns up to 40 and extend up to 400 meter. So we have created our grid, mesh grid, and to remove the extra area of the sheet, we need to go to option environment and increase the value 200 to 20, y1 minus 20, x to decrease up to 420 and y2 up to 320. So it is our domain and a study area. Save it, and we're going to subdivide the mesh, two columns and two rows. Copy and make further subdivisions of the grid for the placement of wells, river and a drain. That seems good now. We're going to save this sheet. After that, uh, layer property, so it is transmissivity varies. It's good for all kind of scenario. So we're not going to change it in both layers. Now cell status, I bound mod flow, make it constant by change it to -1, and by this tab you can copy and make boundary all around the study area. So by using arrow keys, make a boundary. And to make a boundary for both layers, by this tab you can copy it to second layer also. Now save it. After that, we need to set parameters for our case study. Time we're going to change it to days, and initial prescribed hydraulic head go to reset matrices, and we are assuming it -1 apply to the entire model, so it will apply to both layers, layer 1 and layer 2. Save it. Horizontal hydraulic conductivity, set it to 1, apply to the entire model and save it. Vertical hydraulic conductivity, assuming it 0.1, apply to entire model and save it. Then go to effective porosity, also make it 4.1 and apply to the entire model. After that, applying all parameters, we need to place our well locations, both of injection and production well. So we're going to place injection well in layer 1. So by selecting this cell and right click, assuming 25 cubic meter a day, and copy and place it here. Now go to second layer, And there is the location of our production well. So we're going to select here and make it -50. Both layers all set. So we're going to save it and go to flow packages, recharge and reset matrices. By assuming that rechargeability of our reservoir medium is 30 millimeter per year, so we need to use calculator for that. So 30 divided by 1000, it is 0.03 meter, and for 1 day divide it from 365, so it is 8.2 power is to -5, so 8.2 e power -5. The recharge is applied to highest active cell. Okay, and save it. Then go to drain, and we need to place our drain location in layer 1. So I'm selecting this cell and hydraulic conductance, and assuming that hydraulic conductance is basically the product of hydraulic conductivity into the length of the cell. So assuming that our drain area layer is gravels, which hydraulic conductivity is 100, and multiply the length of the cell, which is 10 meters, so it would be 1000, and elevation of the drain -6. So copy, and here it is. But for the other cell, which we need to decrease the value, as they are half of the volume from the adjacent cell. So make it 500, and copy here also, here, and the yes. Now we can save it and run our model. Check model data, regenerate all input files. There it is. Go to PM path now, model PM path. We need to provide particles. For that, select this plus sign and select this injection well. Number of particles 30, radius of 1.5 meter, and number of layers 3. Also to the other injection well. Yes, zoom out, go to the second layer for the injection well, zoom it, also provide particle. Yes. Now zoom out, come to the for cross section, you can see this bar. By placing my cursor here, it shows 15 rows and 19 columns. So for that, I need to go to environment, cross section, 15 and 19. Exaggerate the cross section up to 5 times. Okay, and here it is. For particle tracking, step length change to 30, maximum steps 12. Pathline colors, layer 1, change color blue, and for layer 2, make it red. And check this box, use the following table, ignore the particle colors. Okay, now see, here you can see most of our particles from the injection well are moving towards the drain instead of production well from the layer 2, also from the layer 1. For the contours, we need to go to environment, contours, third level, make it -6 and minus negative 0.1 and change it to zero point 0.2 interval. Visible label format fixed. Here it is, and you can see the particle movement from the injection well towards the drain. So other thing is the river. So we need to save our particle file in our folder river and drain. Named it particles. Save it and close the PM path. Now flow packages and select a river. For river we need to select this polygon and we're going to draw a river here. River or a lake. Right click. Hydraulic conductance of the river bed. Make it 2, head of the river -2 and river bed bottom elevation -5. Select this step and change in these cell because they are less in volume. Make it 1 and copy here, here, and here also. Now it is better now and save it to open PM path again. Here it is. We need to load our particle file, load particles, and search it here, particles. Okay. Now we need to provide particles for the river. For that, we need to go to layer 2, to select this area and provide some particles here. Number of particles 30 and 5 and layers, 3 layers. Okay. By right click, we can provide more particles here and also provide some particles to the layer 1. Going to contours of hydraulic head interval -6 -0.01 and interval of zero point 0. Label format fixed. Okay, we need to make it visible. Check a visible sign here. Okay, here it is. And now we run our model to see the particle movement from the injection well towards the drain and also towards and particle movement from the river towards the production well. Here it is. You can see the particle movement from the injection well towards the drain area and particle movement from the river towards the production well. So see you in the next video. Thank you.